thanks a lot. I'm quite thirsty, so I hope the roller comes at least like in the middle of my talk, so I can be good for the rest of it. Thanks for coming. My name is Jakub. I'm a lead engineer at PipeDrive here in Prague. We have a new development office here, and I will talk today about domain-driven design. So that's the secret acronym here. I feel it's kind of like a niche still term in Node.js community, and I think it's a bit shame because it's a great thing. And so my hope here is that with this talk I might kind of help to spread the word a bit, and maybe we'll have more DDD practitioners in Prague in JS community, because in Java and .NET I think it's already quite widespread. So I don't want to make it a lecture, just going through definitions and stuff. So I thought I would kind of use our own story in PipeDrive, how we started applying it, and what good things it brought, what some issues it brought, and so on. So hopefully this will make it a bit more digestible for you, because to be honest, it's sometimes a bit theoretical and abstract. But with this practical intro, it should be fine. So for that, I need to introduce PipeDrive a bit, because I will be using it in examples. So PipeDrive, what we do here in Prague is this chatbot called Ubiquitous. It's nothing complicated. It's just a chatbot you put on your website. Your website visitor kind of answers a few questions, and then you get information about the visitor, and you kind of reach out to the visitor and kind of make a sale, because that's what PipeDrive as a whole does. The chatbot is defined through this graphical wizard. It's like quite complicated tree, you can move it and edit everything, but it's just like predefined steps here. There is no AI or no like natural language processing, just a statically defined tree. But of course the whole PipeDrive, it's a big company, 600 people, so it's not just the chatbot. Actually the chatbot is the very small part. As a whole, PipeDrive is this sales pipeline tool, and the leads from the chatbot go here to the left, and then real salespeople kind of turn it into deals by like moving it through the sales process. So that's PipeDrive. But actually, I want to talk about the story of Repositories here in Prague. The office is like 1 year old. We started late last year, and we got quite an ambitious goal, like to solve the prospecting space for PipeDrive. This means like to help salespeople get more opportunities, basically, to get more people into that pipeline which you saw. And as you see, it's a broad goal, and it was up to us to decide how we do it. So we did this design sprint, which is like a 1 week long process, and after that we thought that the best thing to do would be that chatbot lead booster. But of course, after 1 week we can't be sure, and in this lean world and everything, you need to have proof. So we started building little experiments and prototypes and putting this works like little static chatbots on websites, and we built first version of this admin interface, which is all static. You cannot move anything. You can just change the copy here and like in those boxes, just to see if people want to use it and pay for it. And happily, we were happy at like first try. We kind of found the good product for us, and people used it. But however, we did it with just the prototype in mind, like with learning in mind. We didn't want to spend ages on making it maintainable and test it and everything. We just wanted to learn if that's the right path for us. So you can imagine the code was in in a bit poor shape. So I created a meme. So that was us, like we had this prototype, but we needed a real product. Like I'm not a meme expert, but I think like I don't know if this is correctly done. But you get it, right? We needed to get from this crappy code base which got us there to something we can maintain in the long term and sell and get money for it and everything. Just for your information, it was like a Node.js service with some React frontend, 10K lines in total. It was working, but it was a big ball of mud. And big ball of mud is not something I came up with. It's actually like a very well described architecture pattern with this beautiful description, which I love, so I will read it out loud. So the big ball of mud is a haphazardly structured, sprawling, sloppy, duct tape and baling wire spaghetti code jungle. We've all seen that. It comes from a I'm not joking, this is a real scientific paper which describes that. And the sad thing is that this is kind of probably the most common architecture pattern which I've seen. Anyway, we needed to get rid of it, right? Like we cannot continue long term with this mess. So we've had some decisions to make. So for the front end part, we decided to completely rewrite it because it was just static, not really nothing we could use. Chat UI, the little box, that was okay. And the backend, we decided to refactor it slowly, right? And the rest of the talk will be about this refactoring of the backend, where we applied TypeScript and DDD and what it gave us. Step one was the TypeScript rewrite. I don't want to spend too much time here. I believe like TypeScript is already quite well-known language here, like really useful in order to know what's happening in your code and like being able to navigate, you know. But I just want to point out that it's not so simple to turn JavaScript codebase into TypeScript codebase, because if you didn't write it, or you wrote it and then you forgot what you wanted to do with that code, you will make mistakes when adding types, and wrongly defined types can be like worse than no types at all, because then you have coupled like parts of the code together which shouldn't be coupled, and this kind of prevents you from making modifications in the future, so just careful there. And we are still kind of paying this debt of introducing some mistakes. But in general, I think adding types to JavaScript is great. Let it be TypeScript or Flow or whatever. DDD is the core of this talk, so I'll spend a bit more time here. So I need to get a bit more theoretical here. So this is actually the most difficult slide of them all. So I'll try to give it a good job here. So domain-driven design. I will use a definition I stole and adapted a bit here. So it's an approach to software development, right? So it's not an architecture, it's not like a design pattern, it's not even a methodology, it's all of it. It's just an approach to software development, and it talks about how you structure code, but also how you kind of how we work together as a development team, and I will explain what I mean. And its goal is to like translate complex problem domain. So by complex problem domain, I mean like some kind of thing you want to solve with software, which is not trivial and also not like very technically difficult, if you know what I mean. So if you are building like an accounting software, there's a lot of laws and rules around it, right? So you can feel it's a complex problem domain. If you are building a web server, that's not a complex problem domain, because it's complicated, right? It's difficult, but it's technically difficult, not really from the business logic point of view difficult. And of course, like we turn this complex problem domain into software. That's the goal of DDD. So that's like what it teaches us, like, or like what it enables us to do. And that now like the different definition, which tells us like how it does it. So that's the main differentiator between DDD and other similar stuff, because it puts the domain, puts the main focus on the domain itself. So that's why it's called domain-driven design, of course. What I mean by that, it tells you like when you start building your software, you don't start by defining a DB structure or deciding what language you will use or where are you going to host it, or you know what I mean, basically all those like infrastructure stuff. You start by understanding the business domain. So if you are building that accounting software, you just talk with accountants until you understand what they need, how they work, what data they work with, like what language they use, and so on. Then you will model that domain in a bit of like abstract graphical way, and then you turn that domain, like your understanding of the domain into software. There's almost like a one-to-one mapping between that your understanding of the domain and software, and again I will explain why. So this is like the important bit, like the software that reflects a deep understanding of the domain. I use the word domain here a lot. I hope it's kind of known what it is. If not, raise a hand. Okay. That was a trap for myself, I hope. All right. There are two main parts of DDD. First, a bit boring part, like it's called tactical patterns. Not a big fan of these names, like all like super fancy names, and which make it difficult to understand. But anyway, tactical patterns is basically how you structure the code. That's the like the technical bit, the similar to like other architectural patterns. Like we can, there's like a loose, like it's loosely similar to like things like MVC or free layered architecture or hexagonal architecture and all that. But it goes a bit more deep, like up to the like individual objects in the code. So typically you mix DDD with some other higher level pattern like MVC, and you use MVC plus DDD, if that makes sense. Strategic pattern, that's the differentiator. As I said, this lets you, this tells you what you should do before you write code, so you know what the domain is, and in turn how you should write the code, right? So again, if we compare to MVC, these tactical patterns in MVC would be to tell you should have modal and controller and some views, right? But the strategic patterns would tell you exactly what controllers you should have, like whether you should have just one which does some things, or you should split it in two, just to make logical sense according to the problem domain which you are solving with that software. So now that we covered the theory, we'll look like what we did in Leadwooster, like to apply DDD. So first step in the strategic patterns are logically first. I had a bit different way around. But first, before we write code, we should have all these like exercises with business experts to define the core domain and other stuff. So first step is define the core domain and bounded context. I will talk about this just very briefly because we're lucky. This is extremely important if your system is big, right, and has like different parts. Like this is example of some like drone delivery system, which is, you clearly see that like there is like a drone management part and then video surveillance part, and it's not good to put it into one subdomain because there will be a mess. So you split it into multiple ones, but as I said, we didn't need to do it. It was clearly just one domain for us, plus like external systems, the rest of PragueDrive. So we didn't need to do anything fancy here. And then another step, like create a glossary or ubiquitous language, another that like fancy term for DDD. It means like it's ever-present language. Basically, you need to have a common way of calling things in your domain. So if you have a user, it needs to be known what's a user. Or if you have customer, or if you have I don't know, an item, it needs to be obvious what it is. And it's possible that item will mean different things in different contexts if you have more of them. And the important thing is this language needs to be shared between development team and other like people in the business. Typically, like product management and product owners and all them, they need to use the same language to talk to you and to talk to users. This brings really great clarity and kind of makes the life much easier than when you need to always translate in your head between what product manager said and what we mean in development. And now domain model, that's like my favorite part, or like maybe most important part here. So this is like an object representation of your domain. In other words, here it's like this is a subset of the domain model, which just describes this chat window. There's another part which describes the editor. And we use some like DDD building blocks here. So the main one is entity, that's this. Then other ones that are like called value objects, which are just like a grouping of data for validation purposes and like some convenience purposes. The difference between entity is that entity has an ID and is like lives for a long time, and you can change it. So for example, a user is a good entity because a user exists, and you edit the user, you modify it. But here there are some like value objects. For example, a message is a value object for us because you create it and it never changes. It doesn't even have an identity for us. So you cannot refer to this specific message, you just have a list of messages. And you combine entities and value objects in DDD to define the whole problem domain, and then what's the magic? You go and you just take this from this diagram and you put it to code. So each of these boxes is a class. It's not a database diagram, don't confuse it with this. It looks similar, but there isn't one-to-one mapping between entities and database. But there is one-to-one mapping between entities and classes in your domain layer. Yeah, so just like typical entities would be, for example, user or job, or organization, conversation in our case. Value objects are, you feel like it doesn't have an identity, doesn't have a lifespan, right? For example, address, you just create it and it represents an address, but if you don't need it now, you just destroy it and it's fine. You just create it next time with the same data and you're fine. Yeah, this is just an example of the other part of the domain model where you added the playbook. I want to kind of stress why this is important, or why it's important to do it correctly. And the reason is that when you define this domain model correctly, then your software will make sense, right? Because you define the domain model based on real needs of the business. So you kind of couple things together which should be coupled based on the business requirements. And then it will mean that in the code things are together which should be together. And if something doesn't need to be together because there is just not a business requirement for a conversation to talk to something else, it's not going to be together and the code will be clear, right? So it's not going to be that like bi-directional reference mess which we sometimes see. And now, like, how do we take this model and put it to code in TypeScript? Because I said TypeScript is good for this, so let's see why. This is just a quick one. DDD talks a bit about layers. I will not go into details, but the important bit is that domain layer, that's this domain model and domain services, needs to be in the center, and it doesn't have references to outside world. So there aren't any concerns from infrastructure or like technical bits inside the domain, and that's done like this in order for the domain to become to stay pure, how they say, like not corrupted by some database implementation details and so on. So only like database that's here in infrastructure database can refer to the model, but never back. This is how it's like in our project, just a subset, nothing fancy, just a domain folder, application folder, HTTP folder, so that represents user interface, like API endpoints and infrastructure, everything else like which talks to the outside world. The most important bit here is the repositories which can persist entities. Now entity, so one of the crucial parts of like entity design is that entity can only exist in a valid state. And by valid state I mean whatever your again business domain dictates. So for example, I don't know, if you are defining like a car, okay, now I'm coming up with some different examples. Let's say here, we have a business rule that a playbook, that's an object that defines the chat, cannot be inactive if it's in preview mode, right, or in preview usage. So everywhere where this entity is being created, which is the constructor, we add checks like this and make sure that it never is, those two conditions are never met together, right? We just throw an exception. Here the same, playbook can be deactivated, it's an action user can make, but here in this deactivate action, we check if the usage is preview. If it is, we throw an exception because it cannot be deactivated, the preview playbook, right? So that's one of the rules. And here we see that TypeScript makes this really nice for us because we can make this private fields everywhere. If there is a business rule that some fields will never change, for example, a playbook cannot be moved from one company to another, we just mark it as read-only, just to write like hard code in the domain model that this is not possible, this operation can never happen, right? It's read-only and it's obvious for everyone who reads it. Of course, if we need to expose the name, we just add a getter. That's really nice. That's the opposite to sometimes used Anemic domain model, which I really liked before, but then it caused me so much headache that I don't like it anymore. And that basically means that you have just plain like data structures, and then it's manipulated by services, right? By classes or functions which manipulate the data. And with this model, you need to make sure that this is always in valid state in all of those services which manipulate that data, right? And this becomes impossible if you take into account tests and data coming from outside. This becomes a mess, and you are never sure. You are anxious that what you work with is correct. You just add checks everywhere just to be sure, and it's terrible. So yeah, so it's really nice. Yeah, entity, if you compare two entities to each other, you compare them by IDs. That's what makes them different than value objects. A little bit of a sidetrack, in order to make the type system even stronger and kind of even more obvious what the domain means or the entity means, we can even add strong typing to primitive types thanks to a bit of TypeScript magic. So you see that those IDs are both numbers, but they have a specialized types. And you cannot assign one ID to another ID because it's a different type, right? That's good for preventing some accidental mistakes, and also adds clarity to the code base. And how it's done is by using this flavoring technique, or maybe a bit hack, I would say. It's not a native language feature, unfortunately, but we can define this flavor type in TypeScript, which takes as a first generic parameter the primitive data type. In our case, it's a number here, and as a second parameter, it's the name of this data type, right? And then the type is this alias to just this primitive type, extended with this optional underscore type parameter, which has this static value of flavor type, which is either company ID or playbook ID here. And basically, TypeScript knows that this, if the flavor type is company ID, is not the same as this if the flavor type is playbook ID, so it doesn't allow the assignment. We are just starting with this. It has a bit of downsides and also feels like magic, so it would be better if TypeScript supported it by default. But anyway, that's one tip. Then value objects are quite similar to entities, but as I said, they are immutable. You cannot change them. You can only create a new one. So that's how we do them, right? Every field is public read-only. Never change them, but always expose it. You take things in the constructor. If we had some validation rules, typically you would have some. You would put them here, and you can have some helper functions to help you with working with data. Equality is by comparing all the fields, so just some kind of shallow equal here. There are also domain events and services in DDD, but I will not talk to them. It's kind of straightforward to implement it. It's just this class doing work or class kind of sending events. So I will move on. I will move on to repositories. As I said, repositories here to abstract away the persistence logic. So this helps us to keep the domain layer pure of all those technical aspects. So typically you need to refer to repository from the domain. So we need to have an interface which we can use in the domain. It has some methods as you would expect, but then the real implementation, so in our case here we call it DB playbook repository. Nothing fancy here, just the database logic. You see there is some database implementation details like transactions here, because it can be inserting multiple rows in one operation, so it needs transaction. And this lives in the infrastructure layer, and the interface lives in the domain layer. And there's quite a lot of how is this quite a lot of repetitive code. That's a bit of a downside of this, but I'm personally fine with that. Use case is another example of quite straightforward TypeScript class. So use case is in application layer, and what it does, it only coordinates work between different infrastructure services, domain objects, and so on. So here we have a quick example of creating a playbook. So it kind of differs the logic to create a playbook to a factory, because there's usually some logic associated with creating a new object, like generating IDs, setting default values, and so on. So there are some lines skipped here. saves the playbook using the repository, and then calls some like infrastructure stuff here, publishes some Kafka messages, tracks the usage, and returns the newly created playbook entity. This is an example of what should go to domain event. It shouldn't be here really, but we haven't implemented it yet, so it's here, and it's not a big deal. Just a bit of again, like sidetrack, we use dependency injection in TypeScript. I know that's unusual, but kind of helpful to split, that dependency hell, that everything depends on everything, and makes testable easier. Like, don't even try to read this notation is terrible, like, but it does its job. It's like inversify package, I think. And now I want to talk a bit about like anti-corruption layers, which is not only applicable in DDD, but in general, I would say. And it touches a bit that thing I talked about at the beginning, that we made the types reuse where they shouldn't be reused, right? So what I want to say by this, here your playbook entities should not be the same as, for example, your data transfer object, what you send away through your API or receive. And it shouldn't be the same as the DB model, it's what you save, right? Because if you make it the same, alright, you will save a few lines of code, but then you want to change the DB model because, I don't know, you want to make some optimization, duplicate some data, or I don't know, use a different data type, and you need to change your entity, but entity should be just a pure domain thing, not corrupted by infrastructure stuff. So just please make it different, the types, and add what they call anti-corruption layer, which is just a mapping, pretty much. Mapping from what you get from outside and what you send outside. And some closing words. So there are downsides. Like the biggest one I would say is that the learning curve of DDD is steep. Like it's full of like really fancy and abstract terms, and it takes time to learn it. The code base will get bigger, but easier to understand, so I don't think that's really a downside. And you need cooperation of the whole team. So if you have some people who are not fans and who are actively showing it, that's a problem, and you need to sell it to them. But even though I think it's totally worth it, like if your project isn't trivial and it solves some complex business needs, just give it a try. So as I said, that's my mission for today. If at least one of you looks up DDD after this talk, I will be very happy. And ping me if you do, and we can start a club or something. Some resources. There's some guy who started writing a blog about DDD with TypeScript. It's really good. I recommend checking it out. If this was not enough for you, check things like CQRS or event sourcing, really connected to DDD and really good. And there are also books. This one is the original one, written by the creator of DDD in 2004. Really dense, really difficult to read. I don't know anyone who finished it. I know a lot of people who started it, including myself. And but I read this one, and this was kind of easy to read and quite good. And I don't know about this one, but it's kind of famous. And last closing word, like every good presentation is closed by a quote from Martin Fowler, of course. So any fool can write code that a computer can understand. Good programmers write code that humans can understand. And with DDD, even maybe our product managers will be able to understand the code because it's going to be full of words they can understand. So that's a bonus. Thank you.
Do you guys any questions?
Yes, so actually we have this Ubiquitous language, and can you try to show your manager the code and describe some scenario?
Sorry, you are asking if I can show...
No. So actually you have this ambiguous language. It means that everyone from the team, not only developers, understand your code. So can you try to show not technical person
well,
and describe some scenario?
No, I haven't tried showing them the code, no, because... But like the language is created in cooperation with them, so I haven't tried showing them the code. That would be a useful exercise. But I have to say, like, they have been surprisingly happy to collaborate on creating the domain model and that ubiquitous language. Like, I was surprised, like, they were full of activity and, and ideas and so on, so, yeah. but I haven't showed them the code.
Yeah, just on that question, on my last company we have an entity called case, and case is a reserved word for JavaScript. So in agreement with the guys from POs, we agreed to change to Z, case with Z. So like it is a nice thing that we have done, and it really works to talk to PO guys. And my question is, why did you put the understanding how to save, how an entity is valid to be saved inside the repository and not inside the entity?
I think we had just some temporary conditions there. This was work in progress, so we allowed creating new entities, but we didn't support updating entities yet because it was work in progress. So it was safe. It was there just to throw a nice exception if someone tried.
Okay.
But it wasn't some kind of business rule, right? If it was a business rule, it would go to the entity.
So it's just for protecting the database.
Yeah, and also temporary. Yeah, I think if I remember correctly. Oh yeah. All right. You mean this company ID? That's a long topic. I don't know if I want to talk about this now.
Oh,
That's basically it's like multi-tenant application used by different companies. So we pass company ID to repositories when it's being started by dependency injection, and then elsewhere in the code we don't care about which company uses this or calls this endpoint, because it's all nicely injected into the repository. And this prevents us from, one company editing other company's data.
So it's security.
Yes, security, data integrity, and kind of convenience. Like we could add this check everywhere in every endpoint, but this is kind of makes our life easier.
So I can tell from an earlier code sample that you're using Kafka.
Yeah.
Which one came first? Because DDD and Kafka are usually pretty tightly integrated, or at least I've seen that pattern used fairly frequently. So did you start using Kafka and then discover DDD, or the other way around?
I guess you refer to the event sourcing mechanism, right? When you persist your data as events. So we don't do that. We use Kafka actually only as a message bus, pretty much, as a persistent message bus. So it came first. It was there for over a year or 2 years maybe now. So it came first. DDD came later.
How do you translate domain objects into database objects? Are you for something?
We just use Connects library, which is a really lightweight query builder. So we don't have to write SQL by hand. But other than that, no ORM. We could use ORM, it would maybe be a good choice here, but we don't. And another, I don't know, did you ask about this, technologies or?
Yeah.
Also, this is a good opportunity for me to say one more thing. This is the big model of the playbook, and as I said, this is not one-to-one as the database schema. And we actually save all that from here down as a JSON column, right? But in the domain represented as an actual classes, so that's a good example of domain objects not being the same as persisted stuff.
I have actually a question similar to the previous guy, and how do you actually transform? You said that DTO object should be equal to entity object to DB objects, right? How do you transform between them? I mean, Java has a library where you specify you want to transform 1 to 2. How do you do this here?
We do it manually. I'm sure we could get fancy and bring in some library to do the mapping, but it's not huge, and I don't want to introduce another layers of magic. So I prefer to write a few lines of code by hand, and maybe if it gets too much, we will introduce some kind of magic there.
I see. So you have something like a static method on playbook, like playbook dot from entity, right?
Not on playbook. Playbook shouldn't know about this.
Or no, I mean the DTO. The DTO
Yeah.
will have a dot from entity, right?
Yeah, pretty much. Yeah.
Okay. So, thank you.